and good day. My name is Ong Hui Ling and my project title is Thermogravimetric and Kinetic Study of Malaysian Hardwood Waste through Pyrolysis. First, I will present the abstract. This study characterized the pyrolysis reaction's kinetic properties of 6 Malaysian hardwood: light red melanti, kelongkang, kempas, mengkulang, balau, and resak. Then the most promising field was evaluated by comparing the result. The average activation energy of light red melanti, kelongkang, kempas, mengkulang, balau, and resak were 152 to 176 kJ per mole, 106 to 129 kJ per mole, 118 to 147 kJ per mole, 120 to 175 kJ per mole, 116 to 207 kJ per mole, and 122 to 160 kJ per mole respectively. The diffusional type model best described the hardwood pyrolysis mechanism. Furthermore, the pyrolysis process was confirmed as endothermic and non-spontaneous as the calculated delta H and delta G value were positive. Kelongkang was the best field due to its high reaction rate, low pyrolysis activation energy, and low ash and moisture content. Next, I will present the background and problem statement. Several factors drive biomass conversion such as carbon dioxide emissions from fossil fuel depletions, and increasing electricity demand in Malaysia. Meanwhile, timber industry in Malaysia generated a lot of wood waste. Thus, this study focused on using wood waste to generate energy. One of the ways of generating power from wood waste is through pyrolysis. To utilize wood waste for energy conversion, we must know its chemicals and physical characteristics and its pyrolysis kinetics and thermodynamic behavior. Besides, we need to develop advanced pyrolysis technology with maximum efficiency and conversions at a minimum cost. Thus, we must obtain pyrolysis kinetic parameters to develop and design reactor with optimized efficiency. The research objectives are to characterize the pyrolysis reaction's kinetic properties for 6 Malaysian hardwood using model fitting and model free method, and to evaluate the most promising field among the 6 Malaysian hardwood. Next, I will present the methodology. In achieving Objective 1, TGA was conducted under pure nitrogen environment and heating rates of 5, 10, and 20 degrees Celsius per minute. The sample was heated from 30 to 900 degrees Celsius. After that, the TGA data was modeled using 3 model-free methods, such as Flint Wall Observer (FWO), Kissinger Akahira Sandoz (KS), and FreakMat, and 1 model-fitting method, Kennedy-Clark (KC) method. Next, in achieving Objective 2, proximate analysis was conducted to evaluate the sample moisture content, volatile matter, fixed carbon, and ash content. Besides, ultimate analysis was conducted to evaluate the sample carbon, hydrogen, nitrogen, oxygen, and sulfur content. Next, bomb calorimetric test was conducted to determine the sample heating value. Lastly, the kinetic parameter obtained in kinetic modeling were used to derive the thermodynamic data such as delta H, delta S, and delta G. Next, I will present the result and discussion. Figure 1 shows the activation energy of wood sample at each conversion. All wood sample shows a similar trend. The activation energy increases at the beginning until conversion 0.3 and then remain almost constant, then drop significantly after conversion 0.7. The variations of activation energy with conversion implies that the process is a complex multi-step mechanism and that activation energy was conversion dependent. Next, Table 1 shows the average activation energy and the best model for each wood species. Both model-free and model-fitting method give similar result except for balau, where model-fitting method give result almost half of the model-free methods. The results suggested that model-free method are more accurate as model-free method shows similar value. Next, from Table 1, kelongkang showed the lowest pyrolysis activation energy. Thus, kelongkang was the best field as it required the least amount of energy to burn. Besides, D3 model was the best model for light red melanti and kempas, while D1 model was the best for kelongkang, mengkulang, balau, and resak. Next, 2 important parameters in evaluating the best field are ash and moisture content. Generally, low ash and moisture contents are preferable. Kelongkang has the lowest ash content, indicating that it is the best field. However, all wood species show quite high moisture content, around 14 to 16%, whereas study reported that a good field moisture content should be below 10%. The high moisture content of wood biomass is a significant challenge in using it as a fuel source. One of the ways to improve it is through pelletizing. Next, the ultimate analysis showed that all wood sample has high carbon and oxygen content, but nearly negligible sulfur and nitrogen content. Larat Melanti and Kelongkang were the cleanest field as they contain nearly zero nitrogen and sulfur, which means lower productions of sulfur oxide and nitrogen oxide. Next, from table 2, Larat Melanti has the highest heating value while Kelongkang had the lowest, which means Larat Melanti was the best field in terms of heating value as more heat released from its combustions. Next, figure 2 shows the thermodynamic analysis result. From the figure, delta H and delta S reveal similar curve shape with the average activation energy as a conversion function. Based on the plot of enthalpy change, delta H dropped massively at the end of the reactions, revealing that only a small quantity of energy is required for the product formations. The delta H value were positive, indicating that the pyrolysis reactions was endothermic. The delta H for Kelongkang was the lowest, which means Kelongkang required the lowest energy to decompose, which agree with the activation's energy result. The delta G value were positive, indicating that the reactions was non-spontaneous. Small delta G difference are observed between various wood and between various combustion, which implies that the favorability of reactions remain the same. Lastly, all results obtained are compared to identify the best field using a weighted ranking system. Kelongkang has the highest mark, which means Kelongkang was the best field. We can relate the result to the wood category, where light hardwood was better field than middle and heavy hardwood. Light hardwood usually has a higher reaction rate and lower pyrolysis activation's energy, as less energy is needed to burn the less than wood. In conclusions, the kinetic parameter was successfully obtained. Model-free method were more accurate and consistent than model-fitting method. Kelongkang was the best field among all 6 hardwood, owing to its high reaction rate, low pyrolysis activation's energy, and low ash and moisture content. That's all for my presentation. Thank you for listening.